Hello everyone. In this video, we're going to be solving a really cool problem. I'm excited. So this is Ramanujan's famous radical, and he worked with nested radicals. He's found a lot of amazing things because it's Ramanujan. What are you talking about, right? He's just amazing. Anyways, let's go ahead and take a look at this equation, and we're going to look at it from an algebraic perspective. Well, this is all numerical, right? But in order to be able to understand what's going on here behind the scenes, we have to use a little algebra. Now, here's what we're going to start with. And this may come as a surprise, like, how on earth you come up with these kinds of things? Well, somebody came up with it, and maybe I copied or I thought about it. And if you keep thinking about these things, they're going to come to you. Anyways, suppose we have 1 plus x times x plus. Mathematicians are weird. Like, why would you think all of a sudden about something like this, right? It's weird, but guess what? It works. So we have something like this, and if you simplify this, it's going to turn into x squared plus 2x plus 1. Now notice that I put the 1 first plus x something because I'm trying to get that type of structure. I'm going to build into that, okay? Wait, this is a perfect square. Yay. So this can be written as x plus 1 squared. Wow, that's interesting. Maybe not. Well, it is interesting, right? But it's going to become more interesting if I square root both sides. And notice that I want to use positive values. So square rooting will not generate anything with a negative sign. I don't want to deal with the absolute value thingy, so I'm going to assume that everything looks good here. Everything is positive. So if you square root both sides, you get the square root of 1 plus x times x plus 2 equals x plus 1, because I square rooted x plus 1, and again, x is positive, so x plus 1 is also positive. Great. Well, we're going to make it greater. So this is the key to the solution. So pay attention to this, because we're going to keep using this over and over. Now, of course, this is true. We checked it, right? But what happens if I replace x with, again, substitution? No. Well, substitution is awesome. That's why we're going to use it. So let's replace, I'm going to write it down here, x with x plus 1. Why? Because we can. So when I do, I get 1 plus, inside the radical, x plus 1, multiplied by x plus 3, and that should equal, on the right-hand side, x plus 2. Now, if you want to check the validity of this statement, of course you can. And think about it. X squared plus 4x plus 3 plus 1, x squared plus 4x plus 4. You can do it mentally too, hopefully. That is x plus 2 squared. Yay, it works. Awesome. We got another identity. So we started off with this identity, and then we got another identity. So you can call this equation number 1 if you want. And just like yesterday's video, right? We numbered equations, so that kind of helps. You can call them, you can use them again. And how about an equation 3? Well, let's go back to the original one, number 1, and replace x with x plus 2. Or you can replace the second equation with x plus 1, but it doesn't matter, same thing. So now, from the first equation, but I like to use the original, because it is the original. So you get the following, 1 plus x plus 2 times x plus 4, but square root that, and that should equal what? Okay, suppose you didn't know what's on the right-hand side. Forget about the first equation. What is this? This is x squared plus 6x plus 8 plus 1, that is 9, and this is x plus 3 quantity squared. So its square root is x plus 3. Easy, right? Wow, this is very easy, right? Math is easy, sometimes. Okay, this is number 3. Okay, is that enough? I think so. So now, here's what we're going to do. To build up to that original expression, we're going to do substitution. How? We did substitution, but we're going to do it again because substitution is cool. Take a look at this. We have x plus 2. And take a look at this. We have x plus 2. Yay! So we can replace the x plus 2 in the first equation with the radical from the second equation. Wow. Is that confusing? I'll say it one more time. We'll replace the x plus 2 in the first equation with the left-hand side of the second equation. I didn't say the same thing, but I hope you don't mind. So now here's what we're going to get from here. Square root of 1 plus x. Now notice that we are replacing x plus 2. So x plus 2 will be replaced with square root of 1 plus x plus 1 times x plus 3. But don't set it equal to x plus 2 because this is the equation number 1. So it's equal to x plus 1. And you can definitely check this. This is x squared plus 4x plus 4, square root that, you get x plus 2, x times x plus 2, x squared plus 2x plus 1, x plus 1 quadrant squared, so on and so forth. Yeah, that was kind of fast, but you get the idea. You can always check it. So this is true, but this is not good enough because guess what? We have an x plus 3 from the second equation. Yay! Why not replace x plus 3 with that? That's going to be even more fun. Let's go ahead and do it. So now here we have 1 plus x plus 1 in parentheses, of course, because the whole thing needs to be multiplied by x plus 3. But instead of x plus 3 here, sometimes notability goes crazy. X plus 3 is going to be replaced with the radical here, right? That radical right there. So let's go ahead and do it. Okay, like this. So I'm going to replace x plus 3 with, I got to do this very carefully now, right? This is crazy. This stuff is crazy. And guess what? If you keep doing this, you're going to get something, you're going to get the same thing over and over. Like, well, not the same thing, but here's what's going to happen. Let me tell you. Look at x plus 1, x plus 2, and the ones are going to stay. And the next one is going to be x plus 2 is going to be multiplied by square root of 1 plus x plus 3 times another radical, so on and so forth. This will go on forever. So we're going to stop here and compare this to the original equation. What was my original equation? Let's go ahead and rewrite it. It was square root of 1 plus 2 times the square root of 1 plus 3 times the square root of 1 plus ... so on and so forth, whatever you want to call that. And we're trying to find this. Well, when you compare these two equations, suddenly you realize, maybe not suddenly, but you should realize at some point, if I replace x with 2, then I get the expression that I'm looking for. Wow, that's amazing, isn't it? Look at that. X plus 1 brings you 3, x plus 2 brings you 4, which I also have in the equation, but I didn't write it. But guess what? This expression right here, I want to erase this, trim this a little bit, so we can use this room. Now this expression is supposed to equal x plus 1, right? Because this is where it comes from, right? The very first equation, remember. So when I replace x with 2, I should do it on the right hand side, and this gives us 3. Wow, was that quick? Yes, but not. Isn't that mind-blowing? It is. Why? Because it's Ramanujan. Again, take a look at his work. Take a look at what he did. The amazing stuff. Unbelievable. Mind-blowing. Spectacular. You know, you'll be amazed. No doubt. So check it out. And the answer is 3. And guess what? This brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I will see you tomorrow with another video. Until then, be safe, take care, and bye-bye.